Alright, so whenever you are doing slope, this is always normal. If the line of best fit is going this way, if you come and project something like this, you can do it at any point so that you can do your vertical axis all over horizontal axis. This is what slope is. So this is always going to give you a positive slope. Once you are moving, your line of best fit is moving in this direction. Always have a positive slope. Then let's say this is your graph, and then you have your line of best fit moving in this direction. So it's more like when you are moving from left to right, upwards, or you can say you are going from down towards the 90 degrees side, that is towards the first quadrant, whichever way, but if you put it quadrant it might confuse it. So once you are moving from left to right, upwards, you are talking about positive slope. While once you are moving from left to right, downwards, you are going to have a negative slope. So notice that if this is my slope now. So I have this way. So, and even it's going to be hard for me locating this on this quadrant, so it's best I put it this way. So you see, so you can now see that this is looking like the Y2 parts. This is looking like the Y1. Then, so this is now looking like my X2. Now let's say we call this X1. I will call this X2. Let's say we still call this one Y1, and then we'll call this one Y2. But what this thing is showing you is that your graph now is on the negative part. So once you have your line of best fit in this direction, that is from left to right downwards, I know these parts where I'm pointing at, where I'm saying Y2 and Y1 might be confusing, but I don't have a unit, but let's use unit and try to simplify it. So I don't know how to imagine it, but depending on the reading you have. So depending on the reading you have, let's say I have whatever reading you have, and when you finish it, you notice that it's giving you a graph. It's giving you a line of best fit that goes in this direction. So if I want to get this now, I'll put it in such a way that it goes this way. So by the time I trace this is the last part. Is it not true? And notice that when I did this part is always standing on the Y1. And this part is always standing on the Y2. Then remember that time, this one is always standing on the X1, and then it's always standing on the X2. So you see that this is now more like I have Y2 will always minus Y1 all over. X2 will always minus X1. So let's say this value is 11. Let's say this one is 7. 11 minus, let's say, sorry, this one is 7. And this one is now 11. So you see, by the time you do it, you're having 8, 9, 10, 11. You're having minus 4 over. Let's say this is normal, 5 minus 2. You're having minus 4 over 3. So it's a negative slope. So by the time you do your graph plotting and you see this, it will definitely lead you well to know what you're doing. Then another example I want to show, another instance is if I have my slope pointing this way, that is horizontally, we say that the slope m is equals to 0. So for this type of graph, we say that slope m is negative, or you say minus 1, so I say negative. So if it's horizontal, I say it is 0, the slope is 0. So I said if the line of best width is moving left to right upwards, we say it's a positive slope. M. Slope is represented with M. So if it's moving this way. Now, if the line of best fit is in this direction, I see it in this direction, so it's pointing towards the vertical axis, we say that slope M is equals to undefined. Say that slope is undefined, M undefined, or we say that no slope, so it has no slope. So you need to know this. So these are the 4 cases, 4 instances, and the principle I normally use to teach my students is that no matter what anybody tell you, the best definition of slope is that it is talking about the change in vertical axis. M is talking about change in vertical axis all over change in horizontal axis. And then from equation of a straight line where we have y equals to mx plus c, anytime you want to find slope, after you must have compared, always compare it in such a way that you have y equals to mx. I seen it. Then take away this x by putting it here so that you make it subject of formula. So we say divide by x, divide by x. So I now have y over x. So this is the same thing as saying equals to m. So you see that your vertical axis and x axis, this gives you the slope on your graph. From your graph you get this. Then whatever you have this facing can give you the same slope. So but this one is always an equation in equation form. Alright. If you go through my videos where I try to do this, you will understand better. Thank you.